All right, guys, you are up. I don't know what you shared with me. Was it not the PowerPoint?
That's PowerPoint.
Oh, that's all you have. Okay, well then that's what you're presenting.
No, I mean,
Yeah, and that's fine. If they have an image, they could tell us.
I have the rest of
Where's the
it.
rest
Oh,
of
there
it?
it is. There it is. Right.
Okay, so you do have more. Okay, so I need you guys to come over, introduce yourselves, and then Robert will join you as soon as he gets the images from the Unity. The camera is right here. The microphone is right here. This is the
Okay.
tab if you want to see their faces. Okay, when you're ready to share your screen, you're going to hit this button and you're going to pick that tab with your PowerPoint so that you can go over it with them.
I see.
Okay, so you both have to be in this picture. So you
Yep.
guys are going to have
Go
to
ahead.
put
Yeah.
your
Go ahead.
faces
Introduce
and
yourselves and tell us which project you're doing.
So, my name is Jared Williams. We are doing the deep space logistics module in VR.
Okay.
I am Simon Dysart, and I am part of the same team.
Okay. Go ahead and share your screen. And oh, we got another person on the team.
Yep. I just had to grab the files.
Okay. All right. Go ahead and share the screen and show us what you're doing. What you,
All right. Share screen. Share that real quick. And yeah, view. My bad. Go ahead. All right, there we go. So we are doing the deep space logistics module simulation.
Mhm.
And what do you call it?
Yeah.
Go ahead.
Yeah. Today we'll be presenting the progress that we made on it. We haven't had much, like, 'cause most of it's been like researching and working on the Unity,
Yeah.
learning Unity.
I've been spending a lot of my time learning C#. You mean?
okay.
Because I've never done it before, really.
Yeah,
What do you call it? It's just C++. Really feels like it. Really. But-
Robert and I have been focusing on getting the models in, mapping out
Yeah.
You have
what
model,
the
right?
yeah
The model.
mapping out the entire place, and then the ship to be in there, the module we'll be using, and then how the physics in Unity will work.
Yeah.
Or-
Yeah. Trying to get like an orbit system and everything. So we
Yeah.
can simulate the transit.
All right.
Mhm.
to the moon.
So our goal is to demonstrate an efficient way for a
like the-
efficient storage layout.
In the deep space like module. So when it'll like be empty, used in first in, first out. Continue on that.
Yeah, the like a pantry, really. Not like a not like a truck. It's more like a flying pantry. That's how I like to describe it.
Sure.
And
Next one.
research we have done, like I've said before, a majority of the research has been really learning the Unity engine and C#.
Yeah.
Because none of us, we've all experimented with like
Unpunch.
Unreal, but Unreal never really works for us. So
Yeah.
we had to, we just had to use the Unity. So
Mhm. Yeah.
which that's been kind of, what do you call it, time consuming, but
Well, but it's
Yeah,
that sort of stuff that's important to do. So the more you do up front,
Yeah.
get familiar with it, it makes it a lot better. So I'm glad you guys are doing that.
it needs to be done,
Yes.
Yep. Yeah.
Okay.
We've also done a lot of like, what do you call it, like the types of packaging that NASA uses. Like we found out like latex, for example. NASA uses latex. It's kind of strange, but no, I wasn't done talking about
Oh,
that.
yeah,
I'm
yeah.
sorry.
Oh,
It's okay.
Yeah.
was gonna
You
say-
guys, yeah, no, but you guys can continue because we want to get to the key things you guys are doing. So
Yeah.
Say,
Yeah. She said we got to speed this up.
Yeah.
So.
I see. Yeah.
All right.
The
So
biggest problem we've had, like, is the trash problem. Really, it's like,
What
do you call
they
it?
may take up to 30% more volume.
yeah,
So we got to worry about like getting more volume in the like thing by like like,
Compress it.
yeah, compressing shelves by pushing them against the wall, like folding them up and.
Yeah, that is in our model. We have what do you call it? Like rotating shelves,
Yeah.
so that like you can place trash like in you can store more stuff. Really.
Yeah. They do
And
the-
one interesting idea, Chinese food, right? It's probably like
Yeah.
the funniest idea. Chinese food. So oyster pail, like those little Chinese food boxes that you get when like you get Chinese food,
Yeah.
they can
well,
fold out into like plates.
Mhm.
Okay.
And our idea was to use something like that that links together to, be structurally sound that we can push the trash against like the wall and like keep it there to gain more space.
Yeah, like with like Velcro or
Yeah, mainly Velcro.
maybe like just designed to just hook together. Really, you mean? But that's like one of my favorite ideas.
Yeah.
That we've had.
Mhm.
That's pretty cool. So, so in terms of so you've done some research on the different development environments. You've looked at some of the physics. You pulled in some models. So where are you
Right
with
now,
pulling? Yeah, where are you with pulling in those models and starting to look at some packages being moved around?
I was gonna say, as for like packing, we found a Python library. It has like a 3D um like simulation of where you can put stuff. So
Oh,
like you
perfect.
load in like
Yeah.
a data set, of like
Okay.
stuff that they use in space and how much they use it, and it will actually, figure out where the best places to put things are.
Mhm.
Okay. Have you been able to use it or program it so you can like kind of show things moving from one to another? I don't know how far you guys have gotten with your
We
programming.
we haven't gotten
I was
that
gonna
far
say,
with it at all.
yeah, I was
We're
gonna say
just-
we haven't, what do you call it, experimented with that yet. We're just trying to, actually get the environment in C# done.
So
Okay.
yeah.
But what do you call it?
Yeah, we don't have the actual like models working the thing. We have the models themselves and we have the area being done, but we don't have like the
have
actual
the,
physics or the
screenshots.
function.
I think
Yeah.
I have a
Okay,
screenshot.
so
I didn't
with
see the
regards
other
to
ones.
that, when you're doing that, you want to do one at a time. So if you have the area, try, and you mentioned you have the Python program that allows you to move it. That's a good start. So show the area, show the Python program moving one thing to see that's possible. Then you can add more, and then you can look at other rooms. So you want to start a little bit at a time, okay?
Yeah,
Yeah.
I think that's
All right.
basically it.
You have that screenshot you want to show?
Oh,
You want to show the what we
it's just like
screenshot?
it's
do you have it?
yeah, but it doesn't show much because it's like not
I see.
So you got,
It's-
oh, you're going to show us a screenshot of something you guys
yeah
programmed?
There you go.
it's well, not the program, but this like what I have so far in my Unity
Okay.
project and stuff. But
What about the ship you had?
yeah, I
What you
forgot about
call it?
that. It's in there, the bottom right, but I didn't like put it up.
I was gonna say you just open the new tab.
Yeah, that's what I'm trying to do.
But yeah,
Sorry about
it-
this.
it's fine. It's
Just give him a moment.
No, you're fine.
Be quick about it though, because we still are.
there you go.
Yeah,
All right.
There we
yeah.
go. There we
yeah, I just like plant setup and just trying to do like an orbit script, like
go.
to
Yeah, you got
down
like the
here.
gateway station that orbits the moon. You mean?
Yeah. So
But
we're still seeing the presentation. I don't know if you guys are sharing
Oh,
something.
Oh yeah,
That's
yeah.
Oh yeah, that makes sense because we got it.
Yeah,
you
you
just
probably
re-
want to close the presentation and then stop sharing and then resharing it so we can see it.
Yeah. Sorry.
Yeah.
No problem.
Where's it at? There it is. There we go.
All right. There we go.
Okay.
Yeah. That's.
Ta-da!
Oh, that's nice. Yep.
Cool.
So
Yeah.
what are we seeing? I see two options.
Yeah, these just basically what I have like done so far in Unity. There's some stuff down here like the orbit script that I'm working on, but
Mhm.
I haven't gotten that far into it because I'm having some trouble with it. But basically, what I have.
I was
Yeah.
gonna say we also have a gateway
Okay.
station. Oh, yeah,
yeah,
like the
yeah. The
gateway
mod
Yeah, the
like
gateway
down there, but I haven't like
Okay.
Like the
put it in there
moon.
because I gotta
Mhm.
rescale it.
Can you
Yep.
double click on this? They can see it.
That's probably
no,
what
this
would
is
be
an
our next
image,
move.
just but like
the measurement.
yeah.
gateway, so
Okay.
we can.
And you guys are working on this as a team, so you
Yeah.
each have a copy of.
We have a
right?
GitHub, yeah.
Yeah.
Yeah,
All right,
we have
good.
like a Google Drive because GitHub was working, but that's what we have.
Yeah, and I would say as part of your presentation, since you have a GitHub, make sure you include that because that's something we can always go and look. And then, like I said, what you want to do is don't make the project too large. So right now, just start with a room.
Yeah.
You have the program, try moving things, get that working, then you more. So just move it within the room, then you can add another room. And then I like your the Chinese pail rotating shelves. So make a list and then just slowly add to it because you want to start getting, like one room working, get that program and then go to next. So if you haven't done that, that's probably how you want to itemize it. And then you can expand from
Start
there.
with the- Because that's what you're supposed to be demonstrating of the sun. the earth.
Right. So, and I
Yeah,
think, I think unfortunately, the way that this project is written, there's just so much in it, right? There's orbital mechanics, there's refueling. And so I think that probably the best thing to do is what Nancy said, pick a section of that you're comfortable with. And that could be used for this VR simulation. I think that you probably get the best bang for the buck about pulling in models of a space station or
Mhm.
models of something that you're going to use for a cargo transfer, and find ways to, like you said, kind of pull those 3D models in and be able to organize them. I like the idea of using a Python script to optimize how they're loaded. Make sure that you're documenting that that's kind of your approach, that we've pulled in these models. We're either using these standard storage containers or we've got this neat idea for a unique storage container that can be used in part of the project. But then focus on kind of playing with and making that VR environment. If, and Mr. Hayes might have some contrary advice to this, but I think probably focusing on that and not so much the orbital mechanics might be a good use of your time.
At least
Maybe
at this point,
at
early,
least at
yeah.
this point, yeah. And maybe if you get through some of the stuff on the VR and it makes it work well, you can start to incorporate things that might help. Certainly if it's like a VR background where you can kind of see, oh, this is we're part of the ascension part of the mission. You can see the Earth kind of fall away. That might still be difficult. So focus on part of the mission sequence, right? You're on your way to, or you've made it to the gateway. You don't have to worry about the launch, but here's how these different components are happening. Focus on that first, and then maybe start to incorporate those other sections. And that way, hopefully, you can get a little bit more traction. Because right now, there's a lot of stuff you're trying to do at once, and it might be
Yeah.
kind of diluting the talent, so to speak. Does that make
Yeah.
sense?
I've asked them to focus on visualizing their storage solutions.
Yep.
Rather
Yes.
than having the sun and the earth. What
yes.
does it look like inside?
Yeah,
Yeah.
and I agree definitely what you're teaching. It's kind of like Cody and I said, pick a room, move stuff there, get models that already exist, get programs that already exist. And if you do that, you'll find out you're going to be able to make a lot of progress in that time because a lot of information exists out there that you guys can use.
The other thing that's it's a little silly, right? But some of those mobile app games, right? Like Moving Out 2, where you're kind of doing things and moving like 3D dimensions in a box. There are some apps out there that actually have that concept where the game is literally how do you get all this stuff into a moving box, and you get better points for how you do it and more compact stuff. Not to say you can open up that code and see what's going on, but it might show you different ways of how some of these simulations or games work. So it could be something to look at.
Okay. Do you guys have any
Cool.
questions for us?
I don't do.
I can't think of anything.
Okay.
Okay.
Well, hopefully that helped.
you
Like I
explained
said, I
Yeah,
think
that was very
focusing.
informative.
Yeah. Okay. Sounds good.
All right, so we're gonna have the next group come over, which is, I think, Cassidy and Oliver, right? Did you share your presentation with me? Okay,
Okay. And which project is this one?
this one is the machine maintenance AI.
Yep.
The officially it's called let me close this down. Officially it's called I have to look it up because I sent it
Yeah, I know.
yesterday. Officially it's called the it's the 2-chamber lunar lab and habitat, but it's specifically the AI under item 3.
Okay. The two, yeah, this is the one I thought, okay, this is the Lunar Lab I was thinking about. Okay.
Okay. All right. So once you put your PowerPoint in, when you're ready to share, You're gonna hit this button right here and pick the PowerPoint, okay?
Yeah. Sure. That's it. Sure.
Yeah, this is the one that's tied with the Luna camper.
Yeah, this is the one that we're baking the logs on.
Okay. So this is the
Yeah,
one,
this is-
implement the AI ML system to predict required maintenance?
Yes.
Okay.
Can they see it?
Yeah, they can see it.
And can they see us too?
Off
Yep,
to
we
the
can
Yes.
side.
see you on top.
Yeah, I wouldn't,
You want to do that?
I wouldn't, because I
Okay.
don't know if that's transmitting that tab or not.
Okay. Ah, oh my goodness.
Yeah, if you,
Can you still see it?
I
Yeah,
can,
we're
can
good.
you put it in presentation mode so we can see it?
Okay, yeah, okay, sorry.
Like this? Like this? Is
Can
that
you see it now in presentation mode?
It's not in presentation mode yet. Actually
Okay,
on the
so
bottom,
that's because of how it's shared.
That's
Um,
okay.
okay,
Yeah,
that's-
if you
that's
exit
fine.
presentation mode, that's fine.
yeah, that's fine.
this?
She just ended
No,
the
no,
call.
you're fine.
She
you're
just
fine.
ended the call.
Let's go, you're good.
Okay, can you guys see it?
Yeah,
Yeah,
go ahead
we're
and,
good.
yep, introduce yourselves and then tell us what you guys have done.
My name is Cassidy Darty,
My name's Oliver Moore.
and we're focusing on the systems and machine maintenance AI, which we named SAMA.
Okay.
Our mission for this project is to summarize the logs of different parts of the eclipse and analyze the logs and alarms to determine preventative maintenance.
We're currently working to achieve this goal by calling different water plants and seeing what information they have about the logs, when the water needs to be tested, and whenever the water needs to be rebalanced. And then once we understand this part of the eclipse, so the water, then we're going to look into the other systems and get a deeper knowledge on them for our logs.
When we started our research, we looked into the different types of machine learning, which we had to choose between supervised and unsupervised. We also had to choose which different kinds of algorithms under each supervised and unsupervised, such as linear regression, decision trees, and k-means clustering.
We also started by understanding the three systems that were already used on the spacecraft, which were the water recovery system, the air revitalization system, and the oxygen generation system.
We started by choosing the learning algorithm and machine learning style we wanted to use, and in the end, we chose to go with supervised and decision tree due to the fact that the data would be given to us in logs. So the AI would have data that is structured to start with.
And we also chose this algorithm because we know that the data will be sent back to us in a specific format, so to make it easier for us to understand. And then after figuring out what we wanted to use to analyze the data, we chose Matplotlib to visualize the data so that we know that it'd be coming back to us and it'd be accessible for everyone to read.
Our project needed to meet the requirements of an AI system outlined by the NASA HUNCH program. These requirements were not just about building a system, but ensuring it can operate in a high-stakes environment like space. We have to design the AI to be capable of processing vast amounts of eclipse data efficiently.
The requirements included us to create our AI to identify early faults in each individual subsystems. And then we also needed to prevent catastrophic failures. And we also
Yeah.
needed to classify the faults accurately, which whether they were minor faults on the watch list or if they were emergency attention from each, so that these can help the on-Earth and on-station maintenance team to understand what's going on in the systems.
There were many different paths we could have taken, including unsupervised learning techniques. These could have allowed us to detect anomalies without predefined labels, which might have uncovered hidden patterns in the data. However, unsupervised learning can be prone to false positives.
Another path that we could have taken could have been deep learning. So using logs like LSTM, which is long short-term memory for time systems analysis. But after careful analysis, we determined that the decision tree would be best because it takes the statistical methods like rolling averages and we just combined them with the decision tree, and it's the most effective and interpreted solution for our requirements.
Implementing this solution was not an easy task. We had to become proficient with tools like scikit-learn, the decision tree model in particular, required us to carefully pre-process the data and ensure the model could handle the various types of data that we would be handing off to it in the eclipse logs.
We also had to implement methods such as Z-score, which is a standard deviation method and it shows which points are off the line that's pretty average. Shows which kind of anomalies are there. And then this was also crucial for predicting when maintenance might be required in specific types of systems or subsystems. And then we also needed to integrate the methods into our AI system to ensure that it would work seamlessly. And Decision Tree took a lot of implementation and testing for that. So this is a picture of our AI that we created so far. It's not 100% working right now because we're going to keep working on it.
What does
So-
it do?
All right, so your AI is the code. Is the AI going to have an interface? So this is mainly the code for the AI you're showing us.
Yeah.
Yes, right.
So
Okay, cool. There you go.
Right now, there is no interface that I have, we have developed so far. But it is something I think that we are planning on as a group to eventually have done.
yeah,
Okay.
we have output graphs and stuff right now. So
Right.
that
And then
just
for the-
shows what's going on in it.
Okay, and then for the input, are you putting input in and training it, or are you entering it manually?
So
mean, is it
that's
like-
the part.
Oh,
Sorry.
go ahead.
So that's the part that we created the logs for. So we created those
Okay,
logs and then we're having the AI take those logs and figure out what's going on in them, output what's going on.
Okay.
Yes, there's yes,
Good.
training.
So yeah, we're training the AI to take the
Okay,
take
okay,
the-
perfect. Yes, that's what I was wondering. Yeah, so the AI will take the input and that's how you're training it. Okay,
Yeah.
so, all right, cool.
This is one of those this is one of the two teams that I said they're working with fake data. So we
Yeah.
think it's
So-
working. but
yeah,
we don't
so-
have real data to work with.
I know. So this is where I think I can help you. I want to see your test and evaluation, but if you can provide me, say, the format for it, like, is it a CSV file or is it an Excel file or something like that? I'll see if I can get, some data for you guys, but go ahead, keep
Yeah,
going.
the format of the data we're looking
Yeah,
for.
yes, that's where we need, yep.
It is actually a CSV, yes.
Okay, so if we can get a copy of one of the instances of that data that you're using,
Mhm.
with a header file, so we kind of know what's going on there, then we can kind of see if there's other folks that can grab it. It might be a challenge for us to do. We don't always get access to that type of data, but we will certainly
Yeah.
try and find it.
Mhm.
But just so you know, it might be a challenge, so it's not going to be super
Okay.
quick.
And then, so for testing, we created the simulation environment. We created a script that would create a CSV that would have both normal and abnormal data, and that allowed us to validate the AI's ability to correctly classify the health of each subsystem.
We evaluated the performance of our model using accuracy metrics, confusion matrices, and real world scenarios. So in this system, we have things that would be real, kind of ones that could trick it to see if it would come back with a false positive. And then we fine-tuned our criteria for ruling averages and anomaly detection to minimize false positives and false negatives, ensuring that the system could reliably predict maintenance needs. So
Okay.
this is an example of what our logs output. And this is our code for our logs. And then this is just more in depth, like more of the logs that would be outputted.
Okay,
When you said you had real data, this is the data from the
that you
Oh.
generated, or,
Yeah,
Yeah.
that's the made up data.
Yeah.
Yep.
okay. So with the made up data, because I know you mentioned, well, once you guys go ahead and finish, you only have a couple of pages, then I'll ask my questions.
Okay.
We're looking for one area for improvement is we would like to integrate real-time data streams from the ECLIS. So we would have data continually being fed to it and the system running live, and that would enhance the system's ability to provide immediate feedback and predictions.
Additionally, we'd like to incorporate more advanced machine learning techniques, such as assemble methods or hybrid methods, which take many different methods and bring them into one to make sure that it's working better. This could improve the accuracy and the robustness of the system. And we're also exploring better ways to visualize the data in the graphs, so that it'd be easier for everyone, the engineers and the decision makers.
Throughout the project, clear communication was vital. We documented every step from initial data collection to model implementation, ensuring that the process can be understood and replicated by others.
We also focus on making the results accessible. So using clear visualization, such as decision tree graphs and trend lines, so that both technical and non-technical people could understand what our data is outputting.
Okay, no, very good. I think using a decision tree is great. We use that a lot at NASA. So going back to your one comment, so I guess for this project, is your plan to do 3 of the E-class areas? You mentioned water recovery, air revitalization, and oxygen generation. Is that okay? You do know E-class covers more than that, correct? Okay, so what might be good to do is to list the different areas, but then say for this particular project, you're just focusing on that because there are a couple of others. Now, with regards to the water reclamation system, for example, is the assumption you have a system here and here are my normal operating conditions, and then is that what you programmed in?
Yeah.
Okay, so when you said you made up the water recovery system, was there anything you use as the basis for what you're calling typical or average water recovery?
We called some of the water plants and asked them what the normal levels are.
Okay, good.
And like asked, yeah.
Yeah, so you want to include that in here? Because right now, when you said because you just said we made up some data, I don't know where it's coming from. So that would be good to have a page that says for water recovery, I received the information from this. So, and then you may be able to identify some of the header files, some of the items you're looking for. That'll also be good to do for air revitalization and oxygen. So I'm glad you guys did that because that's good information to include going to an actual resource. Part of the reason I ask is because on station things may be a little different. Did you do the same thing with the air revitalization and oxygen?
We're getting to that. We haven't done that part yet.
Okay, no, which is fine, but at least you've done it with water recovery. No, very good. And like Cody said, if you can give us the header file you have for water recovery, this will be a good test. We can generate something, send it to you, and we'll note to you which one is good and bad, and then we could see how well your program works. So that's real good. Yeah,
So
Cody?
when you note the data, it could be beneficial to call it something like a fabricated data set from these sources, right? And so made up, of course, doesn't sound great, but if you do a fabricated data set, and this is our inspiration, we've got the water recovery data, we've got this other data. Once you have that, that could be good. It might be a little bit of nomenclature, but that's okay. I think it's important to note. I think the supervised method is good versus the unsupervised one. I think I like the idea of potentially going back and processing it through a couple different methods to see if you can find something neat in terms of an edge case. Maybe you didn't know you needed to, right? I think that's one of the benefits of using an AI or an ML type approach is that you might be able to find trends that didn't exist or people haven't noticed. So that's kind of slick. One question on the matplot library, is there, do you have to include the whole thing? Are you worried about using things or including things you don't need to, or is that not really a concern?
We were not really concerned with including things we did not need. We just included the entire library into the program.
Okay. And I don't think it's a problem either, but if you keep pulling in different libraries, sometimes that could make optimization, or when you run this engine, it might slow it down eventually, but I don't think you're there yet. It sounds like you're keeping a good tab on it.
Yep. And then one thing I can do is with regards to the E-class areas, like Cody says, it may be hard to get actual data, but I do know NASA has published lots of papers about E-class and the systems, what they're recording, what they're measuring. I will look for those papers because from that, that'll help you at least identify what are the key parts of it. And then from there, you can also fabricate more data, like Cody says. And yeah, you want to use that term. Don't say you made it up. Say you fabricated data. That's real good.
We already pulled some of those published papers out,
Oh,
and we've
did
been
you?
looking up and use our data, to create our
Okay.
data.
Great. Yeah, so if you have any questions on those, let me know which paper you're using, and I can also help you because I did do some work way back when on exploration life support, and we did look at the ECLAS system. Because one of the ones I was also involved in, besides those three, was also waste management. And stuff. So, but yeah, if you have any questions, send me the papers you find and I can let you know these because some of them may have a lot. But that would be good. So I know, very good. You
So-
guys have any questions for us? I don't know if Cody have any.
Do you have any questions?
Okay.
No.
No, nice
so-
work.
Yeah,
Oh.
sounds like you're making really good progress. What was something surprising that jumped out at you as you were getting to this point? Something you didn't anticipate.
I know this is like about research, but I did not know they used every kind of water in the eclipse to recycle, like pee and like
Yeah.
sweat and all that stuff. That was surprising to me for the research side of
Yeah.
things.
Oh yeah.
I did not know that.
Yeah.
So
You
that's-
have to conserve everything.
Yeah, but that's
Yeah.
pretty slick, and that's kind of an example of, just because you're doing, a computer science, computer engineering type project, right? There's going to be some physical interface that you have to take into account that might not be so clean, right? Might be kind of dirty, quote unquote, as you kind of use it. So, but that's good
Mhm.
experience to kind of learn that hey, there's always going to be an interface between the physical world and the computer world. So nicely done.
Yep. Nice work.
Thank you.
All right.
You wanna
Yeah. And
say
if you guys
hi
have any
to the
questions, just
camera?
pass it on to your teacher. She'll get it to me.
Okay, thank you.
Yeah.
All right.
I think for them, we're gonna talk about, they actually changed directions on their learning because they tried to go one way and then they went another way. And I feel like they should have brought that up in their presentation that they had to change directions. So
Sure.
I'm gonna
But
make
no,
sure that
they're doing
we have
real
that in
good.
there.
I'm glad they found a local water place. And like I said, with those NASA documents, let me know which ones they're using. I can help them out if they're looking at pulling out key data. But no, I think they're doing good progress. Okay,
All
your
right, so
next.
did you guys share it with me or is it on a drive? Okay, come on over. They're waiting on you.
Okay, and which team is this one?
They're doing the biomedical, it's the psychological. Hang on, they're doing the AI to synthesize medical data.
Okay. Yeah, I think they're meeting with Ally later,
no,
but
they're
let's
doing-
still have them.
Yeah, that's the AI to synthesize medical data. It's the psychological data you're synthesizing, right?
No, it's a different project.
There's,
Oh.
there's several different. Yeah, this.
It's
Okay.
similar, but it's a bit different.
Hang on, let me, they wanted the exact name from the website. So hang on. What's the exact name from the website? Do you know?
Is using AI to synthesize medical data.
Well, that's what I thought it was, but they're saying that there's a specific one for psychological on there.
Yes, psychological evaluation using AI.
That's what they're doing. I was wrong. That's what they're doing.
Okay.
They're somewhere else.
Okay, so when you bring your PowerPoint up, you want to share your screen with this. And then once you hit share, it'll say that you're sharing down here, and that's what you see is what they see. But they can also see you guys on the side. Okay?
So go ahead. You can introduce yourself.
No.
I would.
All right. I'm gonna grab my laptop.
You told them to go get something to take notes on or with.
Oh, good. Yes, that's always good.
That's a good idea.
Only one of you needs to take notes.
Well, it'll be fine.
I appreciate you trying to dress up today, by the way.
I'm gonna be honest. I remembered, and I don't know why.
That's good though.
Yeah, that's the best kind of serendipitous stuff. For like, I do not know why I remember this, but
I try to encourage them to look a little nicer for you. Some did it, some didn't.
it's all right. I also try and look a little nicer every once in a while. Today was not that day, but
Which one do we do?
Well, you have to pull it up first.
Um,
You have to open the PowerPoint first.
Sorry.
Okay, now click on there you go. Now
Click
you
on
want to
this.
share and you want to share a screen, a window. Right now you're sitting on Chrome tab. There you go.
There we go.
There you go. Okay.
Oh wait, we gotta actually get
Oh.
zoomed in. Come on, get out of
No,
here.
that's the best you're gonna get because you're sharing screen right now.
Oh, I thought we could zoom in like presentation.
You can't because then they won't see it because that won't be the screen that you're sharing.
Oh, all right, I guess. Bit scuffed. All right, so
Yeah,
we're
yeah,
doing
go ahead,
the
introduce
cycle-
yourself. Yeah, we can see what's going on, so this works for us.
All right, I'm Cameron Tyree. I am Ethan Goins. We're working on the psychological evaluation using AI. And our main goal is that we need to improve the psychological health of astronauts during long duration space missions. All right. Yeah, it's a big problem for astronauts because I can't imagine them being entirely socially fulfilled in space for months on end with like 5 other people on the ISS.
Yeah, so the example I use is pick 4 of your best friends. Imagine being in a school bus together for 6 months.
Yeah, I wouldn't imagine that being all that fun after a first week.
Correct.
Yeah, so
So our solution to psychologically evaluate them is to be able to read their emotion based off their voice and face, and based off their voice, tone, and such, and the expression on their face.
And we can also listen for keywords that they're gonna say, like if they're feeling down, such like that.
All right, just next slide. We did a good bit of research at the beginning on this, on softwares that can read emotions to our liking. We also figured that for actually being able to communicate with the astronauts, we should probably use something like a chatbot, I'd imagine.
okay.
All right. Next slide.
Come on, Cameron, you gotta read some too.
So,
If you need to read it, but that's not the point of the presentation.
so we need to figure out how to.
Just read it. Just read it. Okay. We need to work on presentations. We need to work on presentation skills because they shouldn't be reading their
That's
PowerPoint.
Yeah.
Just go ahead and read it.
We brainstormed ideas for how we would be able to do a psychological evaluation using artificial intelligence and how could be able to tell emotion. We came up with voice and facial recognition as well as body language. We haven't really looked into the body language yet because that's a little complex. So we want to do that, but that's not in our scope right now.
And that's good. You're showing us you've narrowed down what you're gonna focus on.
Let me just we had specific criteria and constraints that we wanted to do for our project, such as understanding multiple languages, because it is the International Space Station. And we want it to be able to not be affected by background noise in this spacecraft, because I imagine that there would be some, but not 100% sure on that. We want it to be able to be empathetic towards the astronauts and be able to actually tell how they're feeling based off of their facial emotion and voice emotion. You got the next one.
Next slide. We've been. This is just. Yeah, we've been.
Don't worry, that one's apt.
The way it actually works is that we're going to take in user input through a microphone for the voice, and then we're going to read it through a data set and basically just tell if the user, like we're going to look for their tone of voice, their emotion, how they're feeling through their voice, and we're going to determine if they're angry, happy, sad, all other emotions. And for the face, we're going to try to see the face through a camera and we're going to run a script and try to predict the emotion that the astronaut is feeling.
Yeah, we're using Kaggle for our data sets to train these AIs on for the system so they'll actually be somewhat accurate, not just a wild guess in the dark. So that's our plan on how the systems shall work. And for our future improvements, we wish for the background noise to not affect the voice recognition. And for the faces, there's this issue that we're having with it being way too gung-ho on saying random emotions. But so we're trying to get them weighted properly.
Are you prepared to demonstrate it to him?
Yeah.
Okay, so do you need to get the stuff to set up?
It might work on the flash drive with the
Okay.
screen share. It might not. We'll figure that out.
So
Okay, so hit stop sharing.
yeah, so while you guys are setting it up, I have a question. So it sounds like you are training the program. So are you training it with you just said how are you training it? Is it like faces or voice intonation that already exists, or I was just curious.
Yeah, so we have two Kaggle data sets, one for voice and one for face, and we just run the script and it goes through all of the faces and voices and then it tries to predict.
So to interpret that, that means Kaggle is a website that has open source data sets. And they
Okay.
found a couple of open source data sets that they are using to train their AI.
So there's about like 800 different faces, 800 different voices
wow.
of different
Okay.
words. Yeah.
That's where you got the 800 different voices.
Oh.
There's like what 32,000 faces or something. It's ridiculous. But
Why don't
So
you
have
guys see
you-
if you can get it on
Yeah.
here?
all right.
So you
I
guys gonna
can
show
tell
us
you
some?
that they have demonstrated this to Dr. Phillips, and she was impressed because it was literally telling them exactly. It was like, oh yeah, it was showing the emotions on the screen. So I hope they're able to demonstrate it.
Yeah,
So-
I'm just hoping it'll actually run on a laptop.
Yeah. So one suggestion for you guys is videotape a test of it, and you may need to do two different views, maybe one looking at the screen, one looking at the person. So that way you have data you can show. Because like you said, if selected for the presentation, and even when you guys do your CDR, you'll most likely have a laptop there. So if it doesn't work, you want to have the video you could show.
Now you'll have to go back to the conference call and do share in order to share the window that pops up.
Yeah, but I'm pretty sure it has to be the camera window, right?
Yes.
So you have to give it a moment to get to that first.
Okay.
Oh, gosh darn. Oh, yeah, because you don't have the libraries on here. All right, I'll just run it on my computer and then we can just point the
Just
camera. at
unplug
it.
this and just take it over to your computer.
All right, that makes sense.
While they're gonna go ahead and unplug the laptop and just point the camera, or I'll point the camera, and he's gonna
Okay.
bring it up and you can see it. But you can see where they've done a lot of the coding already.
Okay. No, this is good. Yeah.
So I'm gonna close that and yes, stop debugging.
Yeah.
That's the
Because
flash drive.
something else that might be interesting is I know they're doing it on their computer, but can they create a subset that will run on a laptop and they can have
Yeah,
either
the problem is they're running it on my laptop and I don't have their the libraries they're using installed on this laptop.
okay.
So I need to make sure that I find out what libraries they have so that it's
Yeah.
on this laptop so it still runs for them.
Okay,
So give me
that makes
just a
sense.
second. We're gonna go traveling. We're not traveling far.
Going on a field trip.
Yeah, no, then it's-
Let me see here.
Where all this works. All right.
Okay, let me move this so that they can see the screen. Can you see that screen okay?
Yes.
Yes.
How do you put this?
Here.
You gotta like do something like this, and then
The
there,
program's running.
and then we got to get behind the camera.
Okay, so we're gonna move this over here so they can see it because they're looking at that screen.
Yes, and then just drag it over. What?
I'm angry.
Grr. But it's
So
too
get
good at
closer, let
predicting
it,
me.
let it do some.
Oh yeah, I see it's grabbing your
Right.
face. Yeah.
Angry. Goodness.
It's
You gotta
getting
back up
confused.
because
Yeah,
it's got
yeah,
two
yeah.
people. Two people. So Oh, surprise! Apparently,
Surprise. That is nice. It's doing that.
goodness.
Yeah. You may
That's a
you
few
may have to
issues.
read what it
Hang
says
on,
in
I-
red because we can't see it, but you guys may want to read out what it says in red.
Oops.
Oh, I can see that, Nancy. Gotta go to the eye doctor.
So, well, I don't have it. Let me go full screen.
I'm too tall.
Oh, angry. Yes.
Is that how she
Nice.
looks when you don't do your homework? Probably.
Happy. Oh, that is real nice.
It's not the best at impromptu voice faces.
Surprise. Yeah.
Can you see it changing?
Yep.
Yeah. Yep.
Angry. Yeah. Oh, that is
Can you guys see
very
it
nice,
changing?
guys. Yes.
Get my glasses off.
Okay, I gotta share this with Allie. Allie's gonna love this.
You see it up here?
Yep.
Did you accidentally mute them?
I can't hear you. Can you see it?
Yep, we can see it.
Oh,
So they've gotten the
oh, I did
face.
accidentally mute you guys.
Oh.
All right.
So the face
There we
is
go.
yeah, so they got the face working great. Then the next step is to hit the voice. Yeah, I see it. Angry, happy.
That's
Happy,
pretty cool.
happy.
Very nice.
Happy.
Might need to just lower the webcam a bit downward. That'd probably be the easiest.
But how's it taking up the voice?
It's two different programs.
Oh, okay. So we're only looking at the face program right now. They're still working on the voice.
Yep.
Okay. No, this is
So that's
very
what they're
nice.
working.
No, that is real nice. Yeah, I'm gonna
Now-
share this video with Allie too. I think she'll enjoy seeing that. Oh, you guys are meeting with her. So, yep.
So, is this a local installation of the application? Are you pulling
It
data?
is local.
Okay.
Yeah, it is local. Like they were trying to run it from the flash drive because it's local.
Okay, that's pretty
Okay.
cool. It's kind of neat that it's compact like that. So nicely done. One thing to consider, I like all of all the goals that you guys have for the different parts of the project. It might be good to focus on, a specific one. Like for example, you want multiple languages. I think that's great. Maybe get the algorithms or the different nodes of the software trained on English first, so you can kind of
Mhm.
work out some of those kinks before you move on to multiple languages, because I think that's going to be a challenge. And so there's some things that you can focus on for those different applications or those different goals you have for the project. Start small and then incorporate more and more challenges as you go.
All right. You guys have any questions for us?
Nice work getting into the database of different,
Yes. Like get Kaggle. Yeah.
yeah. So that's pretty
that is
slick.
cool.
Yeah.
All right.
What non-English language would you suggest they practice first?
So,
French or Spanish. Yeah.
so I would say historically it would be English and Russian. So,
Well, for
but
space station, yeah, I think
for
about it.
space station it would be English and Russian.
Mhm.
But you can say, hey, look, we know that the two, it could be as simple as saying the two most common languages in the world. English might not be one of them, but the second one, might be, that kind of thing. So you can,
Yes.
that can be kind of tough, right? You don't want to poke anybody in the eye necessarily, but
Yeah.
certainly
mean-
if you,
Yeah.
go
I would
ahead.
say, are either you guys taking language class?
Yeah, I'm taking Spanish.
Okay.
I'm
Well,
not anymore.
well, that may be another one because if you're doing a foreign language, you want to at least have some. So that may be one, and you could say, "Well, I'm taking Spanish now," and you could just demo it, and try it for one or two, a few words and stuff. But yeah. So nice.
Cool.
All right.
Do you have
job.
any questions for us?
Thank you. You have any questions, Cam? No.
Right.
I
Good job.
have a question. How would do you have like any preferred like LLM models, or is it more of an anything goes?
I
The
think it's an
language
anything. I think it's an anything goes. I think you would probably
Monday, you guys are next.
be better to identify those things. I can't think of anything specific that would be preferred over another one. So
Yeah, I mean, I can ask Mike Hayes that because he has some he tends to use his, we don't. So, but like I said, I'm gonna make sure he knows that was a question. You want to know among the ML languages, which ones he would recommend?
LLM.
LLM.
Yeah, which one would just be best for this type of project?
Yep, we can ask.
Yep.
All
Okay.
right, so we're gonna move on to Nicholas and Rade. Did you share your PowerPoint or is it on a flash drive?
Okay. So we have
Okay.
one more.
Theirs is on a flash drive. They're coming over. When you put the flash drive in, you're not gonna be able to have the presentation sharing.
This is the last team.
You can just show the slides. Now I have
Yep.
one more after this, but their team leader's gone, so I saved them for last.
Okay. So yeah, so what I want you guys to do once you're ready is tell us your name and then the name of the project you're working on.
One moment.
And you guys are also doing a software project, right?
Yeah, we're doing the same AI project as Oliver and Cassidy.
The ECLSS.
Oh,
good one.
the
Gotcha.
okay, that the two chamber lunar habitat.
Yeah.
maintenance
Implement an
plan.
AI ML system to predict required maintenance. You guys
Yes,
doing the
okay.
same sub one too?
Yeah, they're doing the same one.
Okay, perfect.
You're gonna share the window and the window you're sharing is this one. Now they're gonna see exactly this, but they can also see your faces, so don't forget to introduce yourselves.
Well, I'm Nicholas.
I'm Rade.
So, like we said, we were doing the two chambers lunar habitat. We were doing the machine learning AI. So, our problem was that we need to go through the ETLSS and look through all the logs of all the various machines and find out if they're running correctly or not. So through this, we did quite a bit of research onto the various types of AI. Like we looked at supervised or unsupervised, deep learning, all that stuff, and then we looked into like a bunch of different evaluation models for. We mostly looked into supervised because we thought that would be the best for what we were looking for. You also told us that supervised would probably been better when we first met. Do you have anything to say on that?
Oh, we had a lot of we stagnated a little bit on deciding on how the model would be structured. And we switched from like a federated learning model to an ensemble learning model. And eventually we just decided to have a bunch of smaller AI talk to one larger AI, and then it'll aggregate the data there and have just one main thing that you run, and it does everything by itself.
So this is what he was talking about a bit, but we at the beginning, before really making anything, we looked into all these different types of models that we could do, and we ended up going with like a random forest type model that we were using.
We also used a little bit of linear regression, so it would be more cohesive and it's more consistent as well too.
So through this, we had quite a bit of criteria to do. We haven't really gotten to some of it yet, but so we had like the training logs that we made ourselves for now, so it's not as accurate or as we'd want, but we have some basic logs to train off of. And we want to have like a categorical way of our AI going, so it will be like it will be a really intensive type thing, or it could be something minor.
Yeah. All right. So for this, yeah, I did a lot of the like implementing when making this AI, and so I kind of just went with the decision to use like a hierarchical approach, and so we'd have a bunch of AIs with a very specific task, like say for like the water temperature, right? We'd have an AI take in data, which the water temperature one or dispensing rate one would have something like timestamp. You can see the example. The timestamp, dispensing rate, and status of it. And then from that, we would give the AI like hundreds of these logs, which it would train itself on. And then we would make another set of logs and then input them to see how well it would do. Um, and we got like a really high, like almost 96.52, if I remember right, um, on it.
What is that 96.52? Is that accuracy?
Yeah,
Yeah, accuracy.
Accuracy,
And
okay.
then
Yeah.
and then a little
Sorry.
bit of explanation for the other one is so we, like you said, we went with more hierarchical, where we aggregate it out at the end. But we did think about maybe having one AI look at all of it so it can look through all the systems. But we thought it would just be better to have smaller AI looking at each system and then aggregating it at the end to have a more cohesive
Mhm.
thought.
It was also more modular too. It was easier to implement and set up. Oh,
So for our solution, we use things like a random forest, TensorFlow, scikit, and linear regression. He was the one mostly going through with the AI, but I looked through all this stuff trying to figure out what would do best, and I thought this type of AI would do best for our situation.
all right. So on this part, I did most of this. Nick did the what you see on the very left, right? Which are the logs and how they look. That's specifically the temperature one. And what I did was the code that you see in the middle and the output that you see on the very right. You can see that like the output has like a main table that shows you like right now it's almost 100% accurate because we've been training it so much. But you can see how like we have two labels right now. We do want to add more later, but this is a proof of concept and prototype mostly. And so we have whether it's normal, so within the ranges that we wanted, or anomalous, which is outside of said ranges, right? And we use we first run it through a linear like regression model, and from that it does more to clean up the data rather than like actually train on it. And then we use a random forest, and we used a random forest because it's really good at taking in like a numerical input and then returning like either a numerical output or like a binary label. Uh, or it can also do like other labels, but you have to do use another like method of uh like evaluating the labels and whatnot.
So for that solution, we we were really just using the logs, so we couldn't have direct input or anything like that, since we're just using the logs to train it. And currently our kind of file layout is a bit weird, so we've been trying to mainstream that.
Mm. I'm currently working on the file layout while he's trying to get it working, working with like the main AI and having it like run together like cohesively. And once we get those done, we're probably after that gonna fix up how uh we're gonna like redo the fake logs. So we sorry. So we can get like more how should I say diverse data, right? And we're also like thinking of making it so that we like put trends in there, and so that our AI can like figure out and then learn from that as well. And then we also need to add like graphs and whatnot and real-time processing.
So this solution is like more of a kind of basic AI compared to what we want for our final product, but it does. So, but for this prototype, we were trying to get a basic solution so we can look at how first off, so we can start learning off how the AIs work and everything, so we can make a better solution. And that's where our refining comes in. Where first off, I am currently working on an aggregation method where it goes through all the AIs that we have, and you can run like a evaluation of an input that it gets, and it directly outputs what it thinks on that specific input for each AI.
Mhm.
And another thing is that we didn't have input yet. Well, interface, sorry. So we're all doing stuff from the command line right now. So we definitely do want to get something more user friendly compared to just using command line.
Yeah. Oh, and I also we were talking about having a CSV output that or not specifically CSV. It could be something more efficient than CSV we were talking about. Because we know that we need to keep a record of the logs that we get, and so from that we wanted to like find a really efficient method. So if we were to save them and store them, we could keep a huge like list and record that the AI can train off of consistently.
So, so for later, we want to have it have an output like we want for the interface to have, you know, a easily accessible way to input logs, and it can also look through a CSV file, see if it changes, and try to see if that is correct. But we'll also have the option for people to manually input data. And then at the end, we also wanted to have like a graph output so you can actually visualize the information. And I think that's it.
Okay, no, that looks real good. So you did mention before, at least for one of your data, you were looking at the temperature. Did you identify which one of the E-class system, at least I didn't see it, that you're focusing on right now?
We were looking at like portable water, just like things with water in general. So
Okay.
with our AI, it's we kind of have like a kind of generic thing right now, but it's very modular. You just need to change a few things and it can work with almost any type of data.
Okay, you want to note that. So, because the thing is, usually with the E-class system, there's several areas it covers. So, yeah, I think the input, the numbers may be similar, but then for example, what the criteria is will change. So that will involve some programming. So if this is going to cover the E-class system, you want to definitely identify, and it's okay to just do one. So like if you're going to do like water recovery or one of the other systems, these are the items that's there. And I noticed you just had temperature. That's a good start. But normally for a system, there may be more than just one. So that is something else you may want to look at. And something we told the other teams, instead of saying fake logs, use the term fabricated. That would be good. And I'm also curious, well, I was going to ask where you got the logs or information, but it sounds like you only had one area. So you may want to look at other systems that uses like either water recovery or oxygen generation. See what's involved in that type of system, and that'll help you because you've already done with the temperature, you have it programmed. So I think adding say another field to your CSV file will be good. I like your plans forward. I like the idea of trying to determine trends because you're correct in that you know everything may show normal, but if you look at it as a whole, you may not realize that the temperature may slowly be going down, but it's still within normal. So I like your idea, and I hope you're able to implement, the trends part to be added later. Same thing with the graphs. Okay, Cody?
Excellent job trying to make it as modular as possible. It'd be really slick to have like a proof of concept where when your project's done, you can say, hey, it's modular and we can accept new data or a new data model, have our system play with a little bit, and then maybe anticipate what you're looking at. The ability to add functionality to it later is very slick. Taking the example of temperature and kind of abstracting it like way out there, is the answer doesn't have to be yes on this one, but is your system able to take temperature data, and even if you don't call it temperature data, can it compare against the other temperature data that it's seen and say, hey, these are all in between 68 and 78, degrees Fahrenheit. This might be a temperature that we're seeing. I don't know if that's something that you can think about doing, but that might be a really slick way. Because then if you get like pressure data, it's always going to be in some engineering unit that's not quite the same. It might be kind of slick to say, hey, we took that data you gave us, random system. We think you've got 2 temperature sensors in there. We think you've got a pressure sensor in there because we've trained it on the models that we've already got for that type of info. That might be kind of slick. I don't know if that's even possible, but it sounds exciting.
I think it is possible.
Yeah.
I think if it has the compatible like file, if it's like both CSV files, for example, I believe that it's if you just like change the field, it would just it would work because like if an AI the AI works on like the field names, and so as long as you just change the field name, like make a copy so you don't like lose the original file, um, it would like be able to train on that and compare and contrast.
Yeah, that might be kind of slick as a neat little extra credit or a neat feature that it can work. Because a lot of times, one of the things that we run into, and you've already kind of run into this already, is data management and parsing the data correctly. If you can have even like someone will give you a file and you have no idea what the headers are, no idea what the data is. But if your system is trained to say, hey, when we see temperature data, it kind of trends like this. Again, this is one example. Then, hey, look, this might be a temperature thing. Oh, hey, system, is it? They're like, oh yeah, it is. You're like, great, did a good job there. Then you can automatically parse, abnormal data from that based on your other systems. Now, for example, some temperatures are appropriate for, let's say, like the living quarters, right? It's going to be between 27 plus or minus 5 degrees Celsius inside something that's going to host humans. An experiment is going to be a lot different. You might be getting it super cold or super hot, but the trends could still be there. So it still might be something like kind of continue in the future. So, but good work. I think.
Yeah.
Go ahead.
So we do have a thing in our, I was working on the aggregation thing. It's not finished yet, but I talked a little bit about it. We have a thing where you can input a new set of logs and train it based on that new set to go with a different criteria, changing environment.
Perfect. Yeah, that's pretty slick. That's, I think, keep developing that and make that part of the system. I think it's going to be a neat feature. Cool.
Yep. I agree. Yeah, no, very nice.
And then maybe, and this could be in your development logs or even in your project history files, but the idea that you picked random forest and you did that for the reason that it was really good at processing, numerical data in and out. Think back and think back, and if there was one thing that was going to push you to a different AI type, what would it be? Not that you have to include all that information, but once you make those decisions, a lot of times the assumptions that go with them fall by the wayside. You can be like, all right, nope, I remember we did that because almost all of our data was going to be numerical in, numerical out, or we would lose that modularity if we didn't do the random forest, right? If we had a federated learning one, it would be kind of tough because we didn't have that stuff. So keep that information in mind. Experts in the field will be able to answer those questions without talking to you, right? Because they know what's going on. But other folks like Nancy and myself are not experts. And so you can say, hey, this is one of the things that we did. So, but it looks like there's a lot of good work happening here. So nicely done.
All right, thank you.
Okay, I have one last team.
Yeah.
Sorry.
I'll let you ask them. I'll go grab the other team.
Okay.
What was something that surprised you in this part of the development? Something you didn't think you'd have to deal with?
Oh, it was the like percentage of how much oxygen compared to other gases there were. I never thought of that.
Yeah, there's not that much, is there?
It's like 30%.
Yeah,
And
it's one of those
sections
things where
hydrogen.
it's mostly nitrogen, right? Mostly inert gases, and so it's kind of interesting that we do all of our respiration on 16 to 25%, 28% oxygen. So cool. Well, nice job. Keep it up.
Yep.
All right, thank you.
So this last group is the merged cosmic calendar team, but their team leader is out sick yesterday or today.
Sure.
So these two were not expecting to handle it without their team leader. So
not a problem. We can adjust as necessary.
Yeah.
Forget to mention your mentor. You
Okay,
did
so-
mentor your mentor, right?
In the slides. No. I'm sorry.
So you'll want to make sure you put him on there as a mentor. Make a note if you need to.
There you go. Is this how I do this?
Well, but they can't see that if you do it.
Oh, okay.
So what we're just gonna do is we're just gonna come over here. And we're gonna hit share. We're gonna share that screen, which is this one. There you go. Now they can see it until you hit stop sharing. So
Okay.
introduce yourselves and then go.
Hi, my name is Elijah Sanders.
Hi, I'm TJ Forbes.
And our project is the Cosmic Calendar. It's us and then our team leader Logan, who isn't here. For our Cosmic Calendar, the problem we're trying to solve is how to schedule events across different celestial bodies, given the fact that each celestial body has a unique day length, year length, and calendar system. Our research that we did the research on each different celestial bodies to figure out their different time zones and day lengths and calendar years and whatnot. Most of the stuff that we found for this project was on nasa.gov. That's the main thing that we used. And the Cosmic Calendar, like, it isn't a fully functioning product, so we brainstormed ideas. For the brainstorming phase, we made an outline of what we would like the finished website to look like. So we have the first page you would see Logan wanted was a server login spot with some sort of username and password, and then we would have a home page linking each of our celestial bodies that we chose, and then we would have each celestial body page. The Earth is just an example, but that's how it would look like for each of one of them.
For criteria, we're just doing time conversion for each celestial body. We mostly want uh t- 2 planets, 2 moons, and 2 asteroids, in a total of 6 celestial bodies, and a working website that correctly converts and schedules time for each event. Our constraints are for scheduling all events across different celestial bodies, and the time in some places have different time zones and also communication delay. And for the website from the previous slide, we stuck with it. It was the best choice for us, and it was a good option. For proposals and designs, we had developed the code for each celestial body for different versions. Right now I will show you an example of for Didymos. Uh, the code is pretty much all celestial bodies have the exact same code. It's just the numbers in certain portions of the code are different. Some are tweaked, some are larger, some are smaller. And to the right, it shows what will happen. Step A is pretty much Earth calculations. And when we get to step B is where we get into the different numbers and different points of the. Well, wait, let me restart that. Step B is where the calculations for the actual planet come from, like the I can't see the Mars anomaly. The wait, I got there was something down here. Mars positions, the part B1. B2 is the angle of fraction for Mars near the sun. That's a small snippet of it.
So the question is, if you go back to that,
Okay.
okay, That's showing the calculations great, but if we were to use that information to schedule a meeting with somebody on Mars, what Earth time do we need? And what Mars time do they need to meet so we can all meet at the same time? That's the
Okay.
question you have to answer.
We
Is that on there?
yes, Earth's calculations are right above all the Mars times, right above. It's like where you see, because I pretty much all the code is exact same. Where it says Titan, really supposed to mean Didymos. Where it says Titan mean anomaly, that's all above it. It's all Earth calculations. That's all parts part A.
Okay, but what's the time? Is that 3 p.m.? Is that for Central Standard, or how do they know what time they're supposed to meet up from those calculations?
Okay,
You're not there yet, right?
not there yet. We're
Okay.
we're getting there though. We're getting
Okay.
there.
That's again, the website's secondary.
Mhm.
That's the problem we have to solve.
Okay,
Yeah.
and for the very last slide, for the celestial bodies we chose was Earth, Earth's moon, Mars, Titan, Didymos, and Dimorphos. Right now, we just got time versions for right now.
So they are working with a gentleman from the Air Force Institute of Technology who is kind of mentoring them through some of these calculations because it is obviously a little bit out of our range. So that's they are getting there. They have it doing some calculations, but they're not 100% there yet. I keep trying to get them off the website to finish the calculations because the website part is easy. Let's get the calculations and the ability to identify what time it is here versus what time it is there, so we know when to meet.
Yeah.
Yes, that's good advice.
Yeah, the
Yeah,
other
so
thing
it's
is,
not-
yeah, the other thing I would say is I like the fact that you listed the planets. I would list those sooner because in your presentation you said we're going to do 2 planets, 2 moons, 2 asteroids. Then you talk about this planet. So that information you want to list, sooner. And then also with regards to the calculations, that's good. But try looking at the Earth and one item, and then another moon, and then slowly add to it. Because I think if you try to do them all together, that may get confusing. And
Yeah,
same
go
thing with
through go through each part of your use cases with the moon first, right? The idea being that that's the closest one. The changes to both the time and the distance for communication lag are minimum, and say, all right, here's how we get through each one of our use cases talking between the Earth and the moon. So we know how our times are set up on the Earth. We can assume that this is what you would need with the moon. You can talk about how you assume the communication lag. I would definitely recommend that first, and then use those models that you have been working on the other celestial bodies once you get that one done first.
Yeah.
Yeah.
Yeah, because that can help you go from one to the other. So, all right,
And
good.
the other thing that's okay to
Trying to
do,
refocus them into leaving the website aside because they still haven't solved the problem.
yes, absolutely.
I agree.
Websites, we don't want to say that they're easy, but they're easier. And unfortunately, because they're easier, you want to play with them more, right? You can play with it. You can say, all right, here's what my login screen is. Here's what this is. I know what these things are. We have the same problem when we do some of our stuff, right? Start tackling the hardest problem first, and then you can kind of shift to the other stuff later. And then one thing to do, this particular project is a little open-ended in terms of what's going on. Feel free to make assumptions that say, hey, the assumption I'm making is, I'm setting a lunar time zone. I'm setting a lunar day. I'm saying, hey, you can't, you can limit the capabilities of the calendar because I'm sure, the calendar can say, hey, look, you can't schedule a meeting within 15 minutes if you're going to do it with Mars, right? It's just not going to work. So those type of things can help you reduce the scope of the project to the point where it's manageable, because there's a lot of stuff in here. I don't know if your mentor has talked to you about, doing an idealized orbit for some of these celestial bodies. It looks like there's a pretty good calculation of a lot of different things. It might be easier for you to ignore some of the parameters. And if you do that, just let us know to say, hey, look, we're assuming an eccentric orbit, or we're assuming a circular orbit. This is just helping us make sure that the calendar can be done. And then you could take those assumptions away if you've got more time to implement a solution to them. And that's a lot of words. Does that make sense though?
Yeah, it does.
Okay.
You guys have any questions for us?
No. Thank you. That was really good advice.
Yeah,
Right. Great.
focus on the calculations, then the website. We know you can do good with the website. The other thing that's neat, I don't know if we talked to you about this before, but there are other tools out there for scheduling meetings. If you go and play with those a little bit, you might be able to find a feature that you like again later after the tough calculations for the orbital mechanics and celestial body stuff is figured out. But like Calendly or like the Google Calendar might be something that you can think of like, gosh, it's really easy if we do it this way. One thing that comes to mind, with as many logins that I have for my different applications, boy, I hate to do another login. So if there's a way to say, we can assume that you've got good credentials. So what NASA does is you've got kind of a card that goes into your computer and it automatically populates all of your passwords to a lot of different websites. That might be something to think about too, so that it's not yet another login and password. Again, you don't have to do that, but it's something that might make the use case or the front facing thing a little bit better. So, but no, keep up the good work. Focus on the calculations. Start with the moon, right? Or something that you can get a handle on before you implement some of the other ones, and just kind of keep working.
All right, thank you.
Yeah, you got it. Good work.
job.
Thank you guys. Take a flash drive. All right, so that's my group.
Right. No, we got through them. That's good. Like I said, I'm gonna share this with Mike. I think we're meeting with
You can-
your
Nancy, you can go ahead and stop recording.
oh, yes. Good point. Record. Stop recording. Yes.